Hi, excuse me. So we're here to talk about logs. Like everybody uses logs in their day-to-day development, but like I would like to walk back and see where does the actual word log come from. What you can see here is a logbook from a ship from maybe 300 years ago. This was something like any ship would have. But I want to kind of focus on what and why would a ship have a logbook like this. So logbooks were used to record important events that happened to a ship, like if there was a storm, if they made it to port. So you could see here on this side of the screen, there's a date. On the right side of the screen, there's some kind of message, like when something happened or what happened actually. And then here we have like another set of circumstances that affected that day or happened during that day, like the wind. Was it cloudy? Was there a storm? So why did ships want to have this kind of information? Well, it was important for them to, for companies that run ships to know how was the voyage, so we would actually inform future decisions. So we see what I really want to focus here is the structure of what a log is, what a log was 200 or 300 years ago. There was some date, there was some, let's call it metadata, and there was some kind of message when something happened. But actually, like logbooks, it starts way before. It was actually a way of measuring this ship's speed. So this is how they would actually do it. So, but we're not here to talk about this, but I do feel it's important to know where a concept comes from, to see how we're actually applying in our day-to-day, to see if there's anything we can learn from it. So what does this have to do with software? So this is the first program almost any person writes. Instead of hello Codemotion, it will say hello world or something like that. It's a fairly simple thing, and like what we're actually starting to use, it's an easy way to get started programming. It's also an using this kind of tools, it's easy to get started logging, like using just a print. There's an error, I just printed the screen. This is what you would actually have in any service you run at a really, really, really high level. Like we do have like an API endpoint that returns the users. There's maybe a web server call, or maybe there's a database call to a different node that can be in your same data center, could be in a different data center. But also, like you kind of need this kind of log to know if something's what's actually happening in your code. So this is like I'm going to be working with this application through the talk to see how we can actually improve the logging of it. So now we got a ticket in Jira that says like, okay, you have to add logs to the application. You don't know anything, so the first thing you do without knowing anything, you start adding print statement. Okay, I'm here, I'm entering this function, I'm leaving this function, this happened here, I exited successfully, I exited with an error. So we can see that like there's a flow, and if we actually like run this code, this is the flow we would see. We see that like we're entering the handle users API, we enter in the checkout method. So reading this log, we can actually reconstruct what happened inside the application. But what happens when you have like multiple requests to your user service happening at the same time? You get this. You get like, okay, so this happened, and then this, but then this happened again, and then this is happening without error and with error. Okay, like you cannot like set an order. You cannot expect to know. There's no thread connecting the messages, as you can see here. This is like the easiest, like this kind of thing happens a lot usually, where you get like people say, well, it works in my machine, so it should work correctly later on. But you see this. So what can we do about it? First thing we can do about it is not actually use print and maybe work with libraries. This is all Go code, so I'm using a library called Logros. There's Log4j in Java, there's Monolog in PHP. There's a bunch of different log handling libraries that like allow you to very easily at least get this, where you get like, okay, there's a time, there's a level, and then there's a message, which is what we saw before. So with the level, kind of like I think everybody's kind of like knows what the level is. But like, let's say it helps you categorize your log messages. But again, you still don't see any kind of like thread running through the application. What's actually happening, you know? And then maybe this happens, that somebody runs your code with a error level, and that means like this is what you get. There's an error, but like you don't have context. There's like you don't know what actually caused that error. You know, so things we know so far. You should maybe add logs to your app. Any app should maybe tell an operator what's actually happening. We need to think what we put and where, so we don't log maybe private identifiable information like credit cards, your national ID card, social security number, your email. Not right now with like data protection laws, that makes these log systems very much harder to maintain. So how can we improve this? Working with what we have. So the first thing we're going to do is try to use any library that supports this kind of syntax, which is structured logging. We start, instead of just telling with text what happened, we kind of start working with some information that like allows us to, some data that allows us to extract information further on. Like for example, this is the code we had before. We now write the path. Maybe if there's an error code, like we tagged it with like a key called error code. We kind of want to know how long the API call took. Maybe if we have an error that says, in this case, authorization code too long, we might need to maybe tell the operator like, hey, your authorization code was this length. In case, for example, you would like call another service and you get like bad password, or maybe if you're changing passwords and it's like it doesn't fulfill the password policy, we kind of need to start adding that information to using this kind of structure. So what we get is this. You know, it's a little improvement. Now we have, like, we can see that there's a structural list. We still have that issue where we don't know when a call starts and when does it end, and we still but we can see maybe if we were able to. This is very easily read by a machine. Right? Logs are now it's in my opinion that logs should not be first geared towards human operators. They maybe should be geared towards machines, which is what's going to consume it first. But then what we can actually do is add a request ID. Very easily, this is like the easiest thing you can do to improve your login experience, for not only for yourself as a developer, but maybe for operators that won't have as much context of the application as you do. So we can see that there are like 3 calls here instead of just the one that we saw before. We have a request ID that, like, if we could filter by it, we could gain a lot of, like, we could actually see like a thread going through the whole application, and we could see when it failed and why it failed. So let's recap a little bit. We have some information, right? We have that information is structured in nature right now, and we managed to track multiple executions individually. So the next thing we want to do is to get that information out of your system. It doesn't make sense in the current world we live in to work with locally available information. Like you might deploy code that runs somewhere, and you need to get those logs to people so they're consumable. You might run with multiple copies of your application, or you might run in different environments. So how can we do that? So we have this tool called syslog. Syslog is a very old logging standard, and also it's known as, if you talk with someone with a SysOps or with anybody else about what syslog is, they're going to tell you like it could be they could be talking either about the daemon or an implementation of the standard. It's an RFC standard, which means that the whole message has some structure. And as we saw before, if we have a structure, we can extract information out of that structure, so we can actually enrich whatever logs we have. You know, we can also our syslog and syslogng, two very popular implementations of the syslog RFC, allow you to run this kind of filter. We have a tag, program name. If it matches your application, you send it to a file, and then you run it again, and you send it now to nowhere else. You only want this this is an example of an syslog filter. We can also be using the systemd journal. So this is kind of years and years ago, or 10 years ago, there were the init wars between different init systems for Linux distributions. You had systemd, Ubuntu had its own. Then there was also init sys5. And then this is one of the more contentious points of using systemd, because what you see here, the journal is the way systemd handles logs, and that journal is stored as a binary file. So you cannot grep it. Any script you had that search through those files will not be able will not work. But then you get this, you get the journal control. Journal control is like a tool that systemd brings in that allows you to actually run filters using metadata stored with the logs. So again, we go back to that idea that logs are just not lines of text anymore. They become structured messages. So we can see here, we want all the logs that belong to Nginx and PHP since today. This is much easier for a developer this is very easy for any developer any person to read than running greps or using AWK or something like that. It also gives you the chance to run an HTTP endpoint, which you can actually use to extract logs. It's called the journal gateway, and allows you to run curl queries like this one. We use it a lot at my company to extract logs out of our applications. So you can see here, there's an endpoint. You just run curl, and when I say curl, it could be you could write your own daemon, or there are also some other options that allow you to read from this journal using this kind of APIs. It could also be that you're lucky, in a way, and you're running containers, or you're running Kubernetes. So Docker and Kubernetes, they have a ton of drivers available, not only for this syslog and journal, also for external services like AWS, GCP, Splunk, also things like Gelf, which is another logging format, that are already integrated in Kubernetes and in Docker. So if we look back, we have an application in our case, or we have some logs somewhere, and then we want to put them somewhere else. right? We have what's called like a log pipeline. So there's this project called fluidy that allows you to run this kind of pipeline fairly easily. It has a lot of like input options and a ton of output options, and it's fairly easy to actually augment it yourself and run it and integrate it with your own in-house system. There are some teams that, like, I know that there are some developers that I work with that I like have used this to integrate with our in-house logging system. So we can actually, they can actually just run a standard, they can just run a standard logging system in their application. They just write to maybe std out. They fetch that somehow, either using Kubernetes drivers, Docker, whatever. And then using fluidy, they start moving that data along and annotating it with more metadata. Like when did it happen, where did it come from, and things like that. You could also be running a system that's like, that looks like this. This is what's called like the Elastic Elasticsearch Kibana stack. We have a data collection pipeline. Then we have something that helps us buffer calls, buffer logs. Then we do some aggregation. We pre-process this information and insert it into Elasticsearch. After that, we can use maybe Kibana or just straight up like Grafana or something like that and connect it to Elasticsearch and use that data for like to see what's happening in our systems. You know, the problem with this kind of pipeline and this one is that it kind of becomes its own job. Someone has to manage this whole thing. It's not easy. You have issues with Elasticsearch, with indexing, and maybe you have to monitor all this. Maybe you want to alert or not, depends on what your business needs are. And because of that, we have this. There's this in the Cloud Native Computing Foundation. There's the landscape. I'm sure most of you have seen it. The landscape is all the companies that have anything to do with cloud computing. And here we can see companies or projects that are related to logging. Right? We can see Elastic, fluidy, Logstash, which is what we saw before. And we can see their market value, which is $7 billion. Splunk is $18 billion. There's a ton of money involved in this. So this kind of becomes like, are you able, your startup, able to compete with this kind of company for running your own log system? Do you actually want to do that? Is the core business value you add as a developer, as a SysOps, related to logs, or maybe just logs are something you kind of need, maybe, or maybe not? Or maybe you don't need 99% of the time, but you need it 1% of the time when everything's actually failing. So we're going to see, we're going to talk a little bit more about this. But as you can see, there's like a lot of money in this business, and that means that it's not actually that easy to run, usually. So Elastic. Elastic works, is a full text search engine, basically. You can also use it as a login storage solution. And the thing about it is like it's super easy to set up, to get started. It's super easy to start dumping information into it. The problem becomes when when you need to actually start managing Elasticsearch. It's a big application. You need to be able to know what your, do you actually care about the data in it? Do you not really care about it? Can you lose that data and nothing happens? So it kind of like, again, becomes its own thing, like that you need to actually manage it. There are some managed solutions for this. AWS has its own thing. They also have like a cloud solution themselves. But again, it's kind of, it might be too focused on search for doing what you want to do. You also have this, which is Grafana Log. This is a fairly new project. This project works in it's very focused on Kubernetes. And it's focused on, you don't actually need to index all your logs. You actually just maybe, what you really care about are the logs about your application and what will happen in your application when those logs were produced. So what this does is like it actually doesn't index your text. It just adds indexes for in the Kubernetes, your pod labels and some other annotations you can add. The thing is, it integrates really, really well with Grafana, so you can actually get like a full view of how is my system doing from a metrics perspective, and also how is my system doing from like what are the logs produced around the same time. So we see that like some companies are kind of all these kind of products, they're evolving to to more than just logs. They're not focusing on logs because the log line that has fairly limited value. What you actually really care about is what's my system doing, right? For that, there's this other company called Honeycomb. I don't know, maybe some of you know it, maybe some of you don't. But what Honeycomb does, it kind of builds up on what we started doing with the really small application at the beginning. We started from with some logs that were just like lines of text. Then we added some structured text to it, like what was happening, some annotations. So what Honeycomb does, it drives way more in that direction. You actually you're not really logging, as in like you're building an event. Like you get a request, and then with that request, there's an ID associated with it, and a user. And that request makes like 10 calls to different web services, and you annotate what the parameters of those calls. And then you get like this gigantic blob that maybe you send to them, or maybe not. Because that's another thing. What it works with is sampling. You don't really care about like the 99% of your requests. You really care about that 1% that like is maybe an error. The database took a little bit too long to call. So what they allow you to do is like configure that kind of dynamic sampling to actually focus and get more information out of like those events you consider much more useful. They're really interesting. I really recommend you look into them. So yeah. And that's kind of it. I know, my name is Joaquin. You can find me on Facebook, on Twitter, GitHub, and I work for BBVA Next Technologies, and we're hiring. Thank you.